Hi everybody, this is Andrea Gasparri from Roma Tre University, and I'm here today as the coordinator of the Canopies Consortium to tell you what our project is about. However, before to get started, I would like just to spend a few words regarding the consortium itself, which is composed by 5 universities, 1 research center, and 4 small and medium enterprises. Canopies' ambition is to develop a novel collaborative paradigm between human workers and multi-robot teams in outdoor, dynamical, and structured environments, such as for precision agricultural settings. As you can see on the right, we envision a farming scenario where farm workers will be interacting with 2 different kinds of robots. We will have farming robots, which will take care of the agronomic tasks, and we will have also logistics robots, which will take care of the logistical tasks. Our approach is to design an efficient data-driven technological solution which is based on robotics and artificial intelligence for the sustainable agriculture of tomorrow. In this regard, we will propose novel human-robot interaction techniques which will ensure enhanced safety and coexistence in the shared workspace. We will also develop novel human-robot collaboration techniques in order to achieve an effective cooperation through explicit interaction. Finally, we will also develop a novel multi-robot coordination techniques to ensure scalability over large areas. Overall, we truly believe that Canopies may have a significant impact in the agri-food sector. On the one hand, we will provide a means to handle the increased complexity of outdoor, unstructured, and dynamical environment, such as for permanent crops. In the meanwhile, we will also mitigate the shortage of agricultural labor, which is one of the major challenges that the agri-food sector is facing right now. In addition, we will promote a better educational model, which is required to interact with the cutting-edge technological solution that will be developed. Furthermore, we will also promote gender equality by reducing the drudgery that is typical of agricultural field operation. In this way, we will also render the agri-food sector appealing again for young generations.
Hello, let me pitch the Horizon 2020 Research and Innovation Project Darko to you. My name is Achim Lilienthal and I have the honor and pleasure to coordinate this project. The consortium includes 2 enterprises and 5 academic partners, which you see here. Darko targets the priority area agile production, so from a business perspective, we are talking about quick adaptation of production processes in response to customers' needs. And the interest is in tools that enhance flexibility in production while maintaining cost and energy efficiency as well as quality. The tools are production robots, which operate in environments shared with humans. For being capable, safe, and efficient, they learn and optimize knowledge and operations. For example, by learning motion patterns in changing environments to choose paths that avoid traffic jams. So what are our objectives and what is the Darko approach? Darko sets out to realize robots with time and energy efficient manipulation capabilities demonstrated through pick and place in motion and throwing of objects with energy efficient, inherently elastic manipulators and flexible end effectors. Second, for safety, efficiency, and legibility, the robots need predictive planning capabilities through human motion prediction, learning and exploiting activity patterns, mutual communication of intent, and risk-aware planning. The third key objective is easy and cost-efficient deployment, which Darko supports through the development of failure-aware and failure-resilient mapping and localization, semantic mapping, and information transfer from heterogeneous map priors. To maximize its impact, Darko is aligned with use cases at the largest manufacturer of home appliances in Europe, and it will be demonstrated at the warehouse and at the Arena 2036 in Stuttgart, permanently showing our effort to lower technical barriers within logistics and agile production. Darko will demonstrate improved autonomous capabilities in AI-enabled 3D perception and scene understanding, and it will go significantly beyond the current state of art in dynamic manipulation, not only for the benefit of agile production, but also for healthcare, agri-food, and so on. This is the project Darko. Thank you very much for your attention.
Felicia, or else flexible assembly manufacturing with human-robot collaboration and digital twin models is a Horizon 2020 research and innovation action project with 13 partners throughout Europe. The main challenge of Felicia is the coordinated human-robot interaction, aspiring to serve the pressing need for agile manufacturing. Felicia combines adaptive workspaces, a cognitive mobile robot collaborating with workers, and a digital twin orchestrating assembly operations. The main project objectives are to develop context awareness via ubiquitous sensing, ensure safety in human-robot collaboration, amplify fluency and ergonomics in collaborative assembly tasks, and orchestrate the assembly process in real time. These contribute to the ultimate goal of realizing collaborative assembly lines for agile production in real environments. Felicia builds upon different baseline technologies that are listed in the left column to develop the competencies indicated in the right column. Of central importance is the digital twin, which will oversee and orchestrate the assembly process with respect to quality, efficiency, ergonomics, and safety. Networking with relevant digital innovation hubs aims to support the exploitation of freemium assets and speed up prototyping. Felicia's framework stands on 5 major pillars. The first pillar concerns smart process monitoring via the integration of heterogeneous sensors and devices in industrial environments. The second relates to collaborative robots with advanced cognitive capabilities, mobility, and adaptability for joint task execution, addressing safety and fluency. The third pillar deals with the AI system for real-time orchestration and control of adaptive assembly lines. The fourth pillar supports a distributed architecture computing paradigm and reusable toolkits, while the fifth pillar is about the technology validation in real industrial environments. Felicia impacts innovation, competitiveness, and market growth through increasing the adoption of collaborative industrial robots by lowering costs with a single mobile platform that can support different workstations and assembly tasks on demand, and with improved flexibility and agility. Improved data privacy and security through a privacy by design approach for handling personal data and security mechanisms for the distributed processing of data. AI augmented automation with the human worker in the center point. The realization of future smart factories. And the interoperability between sensors and modules, expandability and modularity of the developed technologies. Additional societal impacts concern individualism, improved life quality, and workability, healthy and safe workplaces, as well as decreased automation bias.
Harmony is enhancing healthcare with assistive robotic mobile manipulation. In Harmony, we will develop robust, flexible, and safe autonomous mobile manipulation robots for use in human-centered environments such as hospitals. Our 6 objectives target the main technological barriers to delivering systems that can operate effectively in spaces that are not specifically designed for robots. We will formalize object-based perception to capture multimodal scene information needed for robot navigation and object manipulation. We will develop robotic localization and mapping for dynamic object-based environments. We will provide adaptive, congestion-free motion plans as well as joint action planning and execution with human collaborators. Our robots will learn clinically verified grasping and manipulation procedures from expert demonstrations via an immersive control interface. We will develop robust and compliant whole-body motion planning and control for interacting with unknown objects. And we will deliver safety and acceptability recommendations for the use of mobile manipulators in human-centered environments. The success of our project also relies on integrating these technologies into a user-intuitive framework. Harmony targets 2 exemplar use cases to validate and verify our technologies. The automation of just-in-time delivery tasks requires robots to fetch and deliver materials on demand from across the vast logistics network of a hospital. The automation of hospital bioassay sample flow requires robots to unpack, sort, and process incoming patient samples for on-site testing or for redistribution to off-site testing. The fundamental capabilities we're targeting in Harmony directly meet growing needs in all sectors: healthcare, agile manufacturing, agri-foods, as well as industrial inspection and maintenance, and more. Beyond providing flexible and user-friendly automation, Harmony will bridge the gap in existing industry standards to cover mobile manipulators. This will clarify technology certification requirements and remove existing barriers to expand the use of assistive robots, increase industry uptake, and ultimately strengthen Europe's competitiveness in the cobot market. To find out more about Harmony, visit our website, follow us on Twitter, or check out our YouTube channel.
Tracebot, traceable robotic handling of sterile medical products. The objectives and ambitions regarding Tracebot. Today, manual procedures still dominate when it comes to creating and testing new healthcare products, since regulations require understanding of the execution of each process step and systematic checking to verify task completion. Current robotic solutions lack systematic action traceability and failure resistance. The objectives of the Tracebot project are to bring verifiable actions to robot manipulation by reasoning over sensor actor trails in a traceability framework based on digital twin technology. To extend current robot motion planners by the execution of self-checking procedures and create a semantic trace of the actions performed. To extend current robotic system technologies to perceive and manipulate the challenging but regular objects in pharmaceutical settings. The goal is to create flexible robotic systems able to perceive, act, and reason in the pharmaceutical domain, to ensure that any manipulation action is verified, thus leading to the audit trail required in the regulated environment. Tracebot will contribute to several technological fields, while comparing the advancement with the expectations and needs of pharmaceutical and laboratory agents. Our approach relies on, firstly, focusing on a real and challenging use case, which is sterility testing. Secondly, maintaining a permanent connection to the market needs by disseminating our vision and results to pharmaceutical stakeholders and by collaborating with our advisory board. And last but not least, progressing in several technological domains. To maximize impact, Tracebot has adopted sterility testing as use case, a key process in the distribution of medical products. The capability to verify and trace robot actions will overcome a barrier in medical industries. Beyond the sterility testing showcase, the flexibility of the system to adapt to new setups and tasks will help the stakeholders to envision robotic solutions in other pharmaceutical processes. By solving traceability in robotics in general, Tracebot will allow to simplify future robotic applications within the pharmaceutical industry. This is a major requirement to intensify the application of robots.
I'm happy presenting to you our project AI-driven cognitive robotic platform for agile production environments, with its acronym Acroba. We want to deliver plug and produce. At the beginning of our project stands the observation that in a lot of manufacturing enterprises, work is done by manual labor, despite the fact that it's difficult to find labor because the operations are tiresome, bear potential for injuries, need to be done in sterile environments, involve harmful chemicals, can be error-prone, or sometimes simply a third or fourth hand would come in handy. It is our ambition in this project to give those enterprises relief by proposing them a platform which finally makes the use of robots a pleasant and, more importantly, a profitable undertaking. What we want to do from a technical point of view is to build a platform. It will offer a series of cognitive capabilities. During operation, these will be fed by process feedback. Among the capabilities will be a task planner fitting into the existing workflows of the manufacturing and being able to read CAD files and coordinate the robot's actions. Additionally to the task planning, the CAD data will also be used to populate a virtual gym, which in turn is necessary to perform deep reinforcement learning without causing damage. Acroba will also be able to learn from demonstration, which hence is another cognitive capability included. It will be implemented alongside with corresponding tools for user interaction. Finally, to make the actions of the controlled robots precise and safe, the execution of them will not only depend on single sensory readings, but the platform will combine the information from all available sensors to provide multimodal perception. With these capabilities in place, our pilot lines will be able to detach 3D printed parts for sterile medical use from their supports, wash and cure them. They will be able to deburr large injection molded plastic parts, both with little to no interaction in so-called lights-out manufacturing scenarios. They will also be able to wind coils for motors and place magnets on rotors. They will place pin through hole components in PCBs, both together with humans supporting them in collaborative scenarios. And of course, the Acroba platform will easily be portable to other manufacturing cases. To ensure that, we will organize 2 Acroba on-site labs and 12 hackathons. So if you have an interesting use case for our platform, then stay tuned and apply in 2022. You may benefit, like our own use cases, from 50%.
Due to the continuous increase of the world's population, the production of environmentally friendly, sustainable food presents the big challenge of the 21st century. Insect farming might represent a sustainable solution to the challenge of securing food, with proteins for insects being the basis of novel food, and insects also being a valuable food source for farming animals. However, to make insect farming a viable solution, research innovation, the development of farming protocols, and public awareness campaigns on insects as food and feed are dramatically needed. The H2020 project Coresect on cognitive robotic systems for digitalized and network automated insect farms targets the challenges. The ambition of the Coresect partners is to make a viable contribution to securing sustainable environmentally food for humans and animals. Together we bring new insights to automated insect farming and develop novel digitalized integrated robotic solutions. We will create an advanced, safe collaboration environment where humans and robots harmoniously share and undertake processing and manipulation tasks. will also advance AI-based cognitive perception at different phases of the life cycle of the insect farm process and develop cognitive robots with sophisticated capabilities for robotic action planning, manipulation, and control. Coresect's approach focuses on providing a novel robotization and digitalization concept, enabling upscaling and optimizing insect protection capabilities, utilizing state-of-the-art robotization and artificial intelligence. To achieve this goal, Coresect develops cognitive robots, smart mechatronics, as well as artificial intelligence for machine perception and human-robot collaboration, and combines these with new concepts for farm modeling and orchestration, following the RAMI 4.0 framework. In conclusion, Coresect makes a vital contribution to securing a sustainable environmental food production for humans and animals from insects at large scale and in an automated way. Thereby, Coresect has the potential to reduce the risk of international conflicts, to help protecting the environment, and to protect and increase the quality of life of many people worldwide. Coresect will advance the state-of-the-art in robotics, artificial intelligence, and digitalization for industry and agriculture, thereby improving working conditions of workers and boosting the competitiveness of the EU in robotics and AI. I'm Rico Merkel from Maastricht University. Kindly reach us at coresect.eu.
Welcome to the presentation of the Drapebot project. My name is Christian Eitzinger. I'm working at Profacto in Austria, and I will be coordinating this project. Drapebot is about the draping of carbon fiber fabric on a 3D mold, which means taking the flat fabric and placing it in the mold while ensuring that it's accurately placed. We also need to make sure that there are no wrinkles and that the fiber is going in the right direction. Draping may include large patches of material, which can be up to several meters long, and also very small patches, which are just a few centimeters wide. Collaborative draping tries to combine human and robot activities during the draping, especially during the transport of the large patches. But also during the draping itself, the robot will be able to drape the areas of low curvature, which are usually larger, while the human will do the higher curvature areas that are difficult to handle. Overall, we are trying to increase the efficiency of the draping process. The main approach that we are looking at is to perform task and motion planning in order to split the tasks between the human and the robot, for example, during the transport and during the draping of areas of low and high curvature. In order to achieve this, we equip the gripper with additional sensors to allow accurate placement and to have some kind of feeling during the transport of the material. The work cell itself will be equipped with visual sensors to estimate human position and localization and to make a prediction about the intentions of the human. Finally, there will be a low-level control loop that is used to maintain the correct tension on the material and to ensure an accurate draping process. The Drapebot project will have impact on reducing the costs of the draping process. We estimate that 30 to 50% are feasible, and the technologies that are developed will be usable for about 2,000 companies in Europe. At a larger scale, we tried to provide methods that allow efficient human-robot collaboration, and we will have 2 robotic work cells available in the end that are also used for disseminating best practice. If you want to follow the project, then please have a look at drapebot.eu.
Hello everyone, my name is Daniel Calvo and I am the coordinator of Flexi-robots project, which aims to develop flexible robots for the intelligent automation of precision agriculture operations. The project has started in January of this year and will last until December of 2023 and is being executed by a consortium of 16 partners and being led by the Research and Innovation Department of Faros. As you know, during the last years, and thanks to the introduction of new digital technologies like IoT, big data, or artificial intelligence, the traditional tools and services used within agriculture are being radically transformed. In this sense, drones and robots are starting to be used as an additional and powerful way to collect high-quality information from the crops, or even to execute actions like fertilizer spreading or the harvesting. Nevertheless, in most of the cases, current agro-robotic systems are designed to automate just a single task, being highly specialized and working in isolation with respect to the rest of the systems deployed within the fields, leading to low return of investment and higher risks for the farmers. Flexi-robots project want to create a reference architecture and to implement the enablers for building mission control of heterogeneous multi-robot systems that collaborate to accomplish complex tasks, including functionalities for planning and supervision. The reference architecture will support by design the secure and sovereign data exchange, also to store and analyze geospatial information, and it will be interoperable with the artificial intelligence on demand platform. A set of AI services and tools will be developed to exploit available information or to be embedded directly within the robots for perception, decision, and actuation. They will respect the trustworthy AI requirements and will consider ethical, legal, and socioeconomical issues. The project includes 3 pilots with different levels of complexity in terms of crops, geographical location, weather conditions, and national legislations. The impact of the project will demonstrate the potential of robotic systems working in the agriculture domain over extended periods of time, reducing also the commercial and technical risks for the deployment of this kind of solutions, and leading to a wider community where the role of digital innovation hubs will be key to ensure the technology transfer to any European company. You can get further information in the project website or in our social channels. Thanks for your attention, and please don't hesitate to contact us for any doubt.
Odin is a European-funded program aiming to deploy open, digital, industrial and networking pilot lines using modular components for scalable production. In fixed automated systems, although robots are fast and dexterous, their actions are pre-programmed, and it takes a lot of time and effort to add new processes in the same factory. To address this flexibility limitation, new production paradigms have been emerging, empowered by the development of advanced robotics capabilities. Novel perception abilities have been deployed to enable the autonomous operation of robots under fenceless workplaces. Resource mobility has been introduced as a key enabler to assist human operators during production. Advanced safety systems, integrated with powerful artificial intelligence tools, can boost the ultimate goal of seamless collaboration between robots and human operators. The vision of Odin is to demonstrate that these modern robot capabilities are not only technically feasible, but also efficient and sustainable for immediate introduction at the shop floor. To accomplish this, Odin aspires to enable the introduction of mobile, autonomous, environmentally aware and collaborative robotics in industrial settings. Create digital validation tools for these robotic systems to allow scalability with minimum complexity and integration risks. Create an innovation ecosystem to enable the sustainability of open pilot lines, involving robotic application stakeholders and inspiring further deployment. Deploy an integration architecture with open interfaces, allowing the communication of all robotics hardware and control systems through safe and secure means. Odin aims to make a change in agile production towards 3 directions. In society level, by facilitating the production of personalized products, while supporting human operators in production. In European manufacturing domain, by enabling sustainable and cost-effective processes. And in environmental level, by optimizing the use of material and resources. The consortium consists of 15 partners from 8 European countries, carefully picked to implement the vision of Odin. To learn more about our activities, we invite you to visit our project site and connect with us in our social networks.
Robotics and farm automation technologies have seen a significant spike in interest and investment, marking the start of a structural change in food and farming. But for the most part, commercial robotics is still mainly unexploited. Robots for Crops promises to bring a high-tech revolution to farms and offer a tremendous potential impact on productivity, efficiency, and environmental sustainability. We are a multidisciplinary network building a family of fully autonomous robotic systems ready for large-scale commercial trials. In a bold commitment to mainstreaming robotic farming, Robots for Crops will develop a safe testing ground for iterative development and innovation through a network of collaborating partners. The existing agricultural implements and tractors will be upgraded so that they can function together with existing agricultural robots as part of a fully autonomous robotic system. Our flexible and modular new generation system will consist of 3 elements: smart implements, autonomous vehicles, and the farming controller. Fine-tuning and testing will take place in practice under real operating conditions in 4 countries: France, Greece, Spain, and the Netherlands. The focus is on high-value crops and the most demanding and repetitive field operations, namely mechanical weed control and spraying against pests and diseases. At the same time, we will address the compliance with regulations, robo-ethics, and socio-economic impact of robotic farming. Agriculture accounts for around 10% of greenhouse gas emissions in Europe, with little improvement over the recent years. From more efficient crop management to chemical-free weeding, the fields are ripe for robotics and artificial intelligence. Besides, agriculture is very sensitive to the cost and scarcity of labor. Making cultivation practices more efficient and sustainable is critical. While the cost of labor affects the profitability of farming, the COVID-19 pandemic demonstrates that the scarcity of labor threatens the very existence of our food supply chains from farm to fork. Robots for crops will greatly reduce the dependency of farmers on hired labor, increase safety, and reduce the use of inputs and the overall carbon footprint of food production.
Hello. As a former robotics teacher and organizer of international robotics competitions, I have over the years seen thousands of people who are really fond of robotics. And they believe that robotics is definitely a source of innovation as well as economic growth.
As a citizen, I fully acknowledge the benefits that robotics brings. But I also see that people have a lot of questions about ethics, data privacy, and cybersecurity, for example. So, how to tackle these issues?
Well, I believe that ethical, legal, and socio-economical aspects, as well as data protection and cybersecurity, need to be considered in innovation process. The technology needs to be human-centric and consider the needs of people and also the values of the society around us. And this is what we call responsible robotics.
And this is exactly what the Robotics for You project is dealing with. We invite you to attend our workshops, policy workshops, come and co-create with us our maturity assessment model, and companies, you have the opportunity to co-create your robotic solutions together with the citizens.
And at last but not least, Robotics for EU is here to increase your visibility. We will have a virtual exhibition letting the visitors across the globe to interact with robots used in healthcare, agri-foods, inspection and maintenance of infrastructure, and agile production. So we invite you to be a part of that.
Hi, I'm here to present the Axleride project, a smart hospital care pathway engine, coordinated by Helsinki University Hospital in Finland. In this project, we aim to develop a scalable and modular AI toolset for different healthcare use cases. Our objective is to use efficiently the different data inputs that are generated in hospital operations, including IoT and robotics devices. This concept will be tested and piloted within the project in 3 different European countries, and 5 hospitals. The Smart Hospital Care Pathway Engine includes a standardized data input interface, a toolset that can be used in different areas of hospital operations, as well as data outputs and a UI layer. This solution can be integrated to different data infrastructures depending on the hospital's current state. We will be having 3 different pilots, one for patient flow management in the surgical units, one for chronic adult care, and one for chronic pediatric care. These different pilot applications will be testing the viability and scalability of this concept. Our expected impacts include using and allocating healthcare resources more efficiently, providing personalized care and digital care pathways for patients, and optimizing patient flow. We also hope to contribute to efficient algorithm development, as well as evidence-based and trustworthy AI in the healthcare arena. Thank you for your attention.
The new EU Horizon 2020 project Aidpath started in January 2021. Aidpath stands for Artificial Intelligence-Driven Decentralized Production for Advanced Therapies in the Hospital. Promising pharmaceuticals based on genes, tissues, and cells are the so-called Advanced Therapy Medicinal Products, short ATMPs. However, many obstacles still need to be overcome for the wide-scale deployment. One therapy that is already being applied for the treatment of acute leukemia and lymphoma is the so-called CAR-T cell therapy. The manual processes currently used in laboratories cause high costs, require long production times, and have only a moderate chance of success. The Aidpath Consortium has set out to automate AI-powered CAR-T cell manufacturing in the hospital, making this therapy accessible to a wide range of patients. The CAR-T cell manufacturing will take place in the hospital in an automated platform, in compliance with all regulatory requirements. The entire process chain is supported by artificial intelligence, which not only suggests patient-specific process sequences, but also optimizes the whole manufacturing process on the basis of the cell behavior. A secure data infrastructure enables continuous learning of the artificial intelligence and straightforward connection to existing IT systems in the hospital. Over the next 4 years, Aidpath will demonstrate that AI-based technologies are effective for automating the process of advanced therapies. Aidpath will build the basis for a deployable platform so that pilots can be initiated in multiple hospitals. Also, Aidpath will create an innovation ecosystem for a lively exchange of the stakeholder community, driving the concept of the smart manufacturing hospital forward.
Hello, I'm Thanasis Poulakitas, the coordinator of Cosmetic, and I will now give you a very brief introduction to this project. Our vision is to support an effective and efficient healthcare system transformation, which will utilize AI in robotics. Our mission, that is our main objective, is to provide an AI-supported platform that will allow the composition of smart services for healthcare, offering also the possibility to analyze the benefits. The first pillar of our approach is the technology in AI and robotics. The second pillar is the platform. This includes the Cosmetic hub, which is composed of a marketplace, a co-creation space, and benchmarking framework under a uniform user interface. From there, applications are developed and deployed in the application space where they run and provide feedback. The architecture builds from the infrastructure up adding interoperability and control components, then AI services, along with the composition of healthcare applications. The third pillar is our pilots, who will validate our solutions. They cover wide domains from hospital logistics to diagnosis, treatment, etc. They also address a number of medical fields, from cancer, gastrointestinal disorders, etc. Our final pillar is our methodology, an agile approach bringing together the technology providers with the pilots and ecosystem. There will be 2 iterations, and there will also be 2 open calls. What is the impact of Cosmetic? We expect to have strong impact in pilot applications supported by open platforms, in demonstrating the effectiveness of AI-based technologies, and in contributing to trust and acceptance of AI. We aim for a strong impact in engaging the ecosystem and leveraging more funding. Finally, we expect specific important impact from the pilots in the medical fields that were mentioned earlier. Thank you for your attention. For more, please visit us and connect with us.
Hello, everyone. I am Sergio Guillén, Deputy Coordinator of Odin project. Odin is a large-scale pilot project on the transformation of the hospital of the future by artificial intelligence and robotics. Odin envisions the hospital of the future as an organization empowered with advanced digital technologies, improving safety, efficiency, and quality. Odin will use robotics, artificial intelligence, and IoT to build that vision across all operating areas in a hospital. Our goals are the enhancements of the hospital workers' skills, automatized hospital processes, including hospital logistics, infrastructure management, hospital reconfigurations, and patient flow optimization. How are we going to do this? Odin will build an artificial intelligence robotic IoT ecosystem, and it will be deployed in 6 reference hospitals in Europe in a multi-centric pilot implementation. The main area of pilot intervention will be logistics support, clinical engineering and medical device management, AI support system for diagnosis, clinical tasks and patient experience, automation of clinical workflows, home hospitalization, and disaster preparedness. As well, Odin will enlarge the ecosystem beyond the initial pilot, attracting new hospitals, industries, and SMEs to experience the Odin technology and best practices. We will leverage on the European Hospital Living Lab Hub and Digital Innovation Hub networks, which will allow to further enrich the demand and supply sides. In addition to the impact on hospital services, which will be measured through identified KPIs, Odin will roll out an ambitious communication and awareness creation campaign to disseminate the concept, our vision of the hospital of the future worldwide. To maximize the impact, Odin will build an innovative procurement journey, a new business model that will facilitate the digital healthcare adoption, the market scale-up, and investments, ensuring the self-sustainability of Odin value proposition. Thank you very much for your attention.
Artery is going to revolutionize transcatheter interventions. We are going to develop catheters with distributed sensing and actuation that observe the environment and that interpret it and autonomously decide how to move through it. The same sensors that are used to control the catheter provide information to the interventionist. She or he can use this information to provide high-level control commands and position, for example, an implant with greater precision as ever before.
In the Artery project, the operator will interact with the system through an holographic display, which will allow the visualization of the virtual vasculature tree. The operator will also interact with the system through an holographic interface, which will allow him or her to direct the catheter pose. Artificial intelligence module will allow the interpretation of the intraoperative ultrasound imaging and the estimation of the inverse kinematics to better control the catheter pose.
By 2060, about 15 million cardiovascular patients will be in need of optimal and minimal invasive treatments. Artery is opening the era of robotic steerable catheter technology. By shortening radiation time and maximizing procedural standardization, the security and efficiency of interventional therapies will be increased. For the physicians, this brings shorter procedural times, more predictable outcomes, and improved learning curve. For the patients, this is associated with enhanced procedural safety, with reduction of morbidity and mortality, lower complication rate, and shorter hospital stay.
Good morning to everybody. I'm Nikos Sagarakis from IT. I'm here to present the Coresect, which is a new project that we started recently. Coresect comes from configural collaborative robot technologies and target to create a transition from the existing current collaborative robotic systems towards systems that are more flexible and modular and can be used in evolving production lines. We plan to develop a modular system that can be tailored to the requirements of different tasks. It can have the capability to demonstrate different physical performance settings, able to apply high-level human-scale forces against to the environment, and at the same time ensure safety during collaboration with the human operators. Finally, we equip these systems with adaptive collaborative skills that will allow us to arrive to more efficient human-robot collaboration performance. We developed this technology within the consortium that is composed by 6 partners from 4 European countries. From Italy, IT is coordinating the project, Poland, Germany, and Austria. And the plan is basically to reach our goal by developing 4 fundamental technologies. The first is actually robotic modular systems that permit the composition of different robot configurations in order to match the different requirements and the variability of the tasks. At the same time, we provide tools that provide to the user the capability to compose optimal topologies of these configurations, starting from the requirements of the task. We equip the system with safety tools and technologies in order to permit that this system is always safe, independent of the different configurations. And finally, we develop workspace perception tools that will allow to improve the situation awareness of the robotic systems against the environment and the human operator towards more efficient human-robot collaboration. We apply the technology into the construction sector, which is a very promising application area that also at the same time involves high challenges for robotics. Thanks to the variability of the task and the construction environment, the Coresect technology is highly motivated to develop this system that can couple with this kind of challenges. And we plan to demonstrate these advancements and the performance increase using the Coresect technology, using a number of performance indicators, starting from the production efficiency of the task execution, the accessibility and the usability of the technology towards legal aspects, occupational health and safety, and psychosocial aspects of the technology when used by the workers. Thank you very much for your attention. I will be happy to provide you more information, and please visit our website for learning more about Coresect and the coming results of the project. Thank you very much.
Hi, my name is Thomas Vögele and I'm the project coordinator of DeeperSense, Deep Learning for Multimodal Sensor Fusion. In DeeperSense, we unite a consortium of 7 companies and institutes from 3 member states. And our ambition is to significantly improve the sensing and environment perception capabilities, in particularly of underwater robots. We want to do this in 3 use cases. In use case 1, we want to concentrate on diver monitoring under turbid visibility conditions. In use case 2, we're looking at AUVs that navigate in coral reefs. And in use case 3, we want to improve seabed mapping and classification. Our approach to do this is to use the latest technologies in artificial intelligence, mainly deep learning algorithms, for something that we call intersensoric learning. In intersensoric learning, one sensor learns from another sensor. In deeper sense, we want to develop for this purpose 3 different algorithms. The first one, sound to vision, will enable a low resolution sonar to learn from a high definition camera so that the sonar can see in turbid waters. In the second one, eagle eye, a forward-looking camera will learn from a forward-looking sonar to identify obstacles that are way ahead and hidden in the depth. In the last algorithm, smart bottom scan, we want to enable a sonar to learn from camera images how to map and classify the sea bottom sediments. The impact expected from this project is that we will have at the end 3 validated and tested algorithms, and they will be validated in real environments in Germany, in the Starnberger See, a lake in southern Germany, in Israel, in the Red Sea, and in Spain, in the Mediterranean. These algorithms will enable new applications for underwater robots, mainly for robots that have to operate in turbid waters, AUVs that want to explore complex structures such as coral reefs, and in general, the mapping and exploration of the sea bottom with the help of AUVs. However, this new algorithms and new approach of intersensoric learning will not only improve underwater robotics, but also robotic perception in terrestrial, air, and space robots. So it's a generic method that can be used for many different perception tasks in robotics. To make our results available to the scientific community, we will select some of our training data and publish them through an open data repository. Training data are the most important issues in AI, so these will be very helpful for the other partners, for the community to work. Finally, we will establish a close interaction with the robotics community, for example, through workshops and with a close communication with the DIH networks such as RIMA and others. If you have any questions about our project, please feel free to contact me. These are my coordinates. Thank you very much.
Faros stands for Functionally Accurate Robotic Surgery. This is a new project that started in January 1st and will run for 3 consecutive years. Functional accuracy is defined as the degree to which the functional outcome of the surgery conforms to the expected outcome for a successful complication-free operation. Surgeons are not interested in overall accuracy. A gesture is only valuable if it contributes to this functional objective. In spine surgery, reaching said functional objective is difficult due to poor visualization, the need to operate in a dense anatomy and tight space, with nearby vital structures under large variability in tissue and bone characteristics, requiring large forces and deformations, and where conventional navigation techniques suffer from large buildup of errors. Furthermore, they may resort to damaging radiation, and it's also not very well known what actions will lead to an improved outcome in the end. That's why Faros' ambition is to introduce functionally accuracy in surgical robotics. We will reduce preoperative planning and remove intraoperative fluoroscopy altogether. We have a compact consortium of 4 partners that will be developing a wide spectrum of intraoperative sensors that provide insightful signals from the surgical side. We'll be developing functional models that relate sensor data to functional outcome parameters, and will embed physical intelligence in our robots such that they can act autonomously, optimizing the functional outcome. Spine surgery is a highly important field, with the majority of the people supposed to encounter back pain sooner or later, and large associated costs to the healthcare system. Furthermore, manual surgery sees relatively large complication rates due to the surgical intervention. Robotic technology featuring surgeon-like behavior but with higher functional accuracy could change this image significantly in spine or in other surgical fields. Please see here some clips of different intraoperative sensing and control actions that are currently being set up and that will form the base of a new generation of surgical robots. Feel free to check out our project website for more information.
Natural Intelligence Robotics for Environmental Monitoring, an H2020 project coordinated by University of Pisa. Global warming and pollution are threatening our planet. To tackle this phenomenon, the European Commission established the Natura 2000 network. Natura 2000 network is a large area of interconnected region to be monitored, which covers today the 18% of the European land. Natural Intelligence Project proposed a nature-centered approach for robotic environmental monitoring. In this approach, there will be a close interaction between three components: environment, body, and mind of the robot. The project is composed of 8 work packages. 4 of them are devoted to technical activities related to the development of the body and the mind of the robot. These components will be integrated by the dedicated work package and will interact in a feedback loop through benchmarking and standardization activities, and through field validation activities. Everything will be managed by the dedicated work package. Natural intelligence will strengthen the European excellence in robotics, science and technology, will lower the barriers in the deployment of robotics-based solutions, will widen the use of robotics in promising application areas, and will open new markets as robotic monitoring for natural habitat. The team is composed of 10 scientific institutions, 1 small-medium enterprise, and 4 third parties. The partners of the project are University of Pisa, Imperial College London, Polytechnic of Zurich, Kingston University London, National Spanish Council of Research, University of Delft, Italian Institute for Research and Environmental Protection, QB Robotics. Third parties of the project are University of Siena, University of Milan, University of Sassari, and University of Perugia. Join our project at nih2020.eu.
Good morning, everybody. I'm Matteo Cianchetti, Assistant Professor at the Biorobotics Institute of Scuola Superiore Sant'Anna, and I'm serving as coordinator for the SoftGrip project. The fresh food industry is under growing pressure to reduce production costs due to high levels of competition. Moreover, in the specific case of the mushroom industry, it is highly labor-intensive, with much of the manual work requiring rapid, repetitive, and monotonous movement that lead to poor quality control and a high incidence of industrial accidents. Therefore, the food industry is looking increasingly toward automation and robotics to help lower production costs and improve job quality and safety. However, the capabilities of the human hand in terms of dexterity, sensitivity, and precision are still unmet. So the main objective of the SoftGrip project is to develop a self-actuating soft gripper for the autonomous picking of delicate white button mushrooms. Our approach. We will research and develop low-cost soft robotic grippers having built-in actuation, sensing, and embodied intelligence that enable safe grasping, adaptability to object shape and size, and grasping versatility for reliable and efficient picking of mushrooms. We will engineer blending of novel materials that offer precise tuning of fundamental material properties, that interact safely with the food, with minimum impact on the environment, and that provide robust and maintenance-free production over many cycles of operation. We will make use of a set of accelerated continuum mechanics modeling algorithms that will facilitate sophisticated model-based control schemes. Moreover, we will research and develop advanced cognition capabilities in the soft gripper through a learning by demonstration framework. The project is expected to have an impact on 3 main topics. In the specific scenario of mushroom harvesting, we are expecting to enable a step change in efficiency, helping mushroom growers cut down on costs and increase their yields. At the same time, this will increase job quality and safety by reducing the strenuous part of the mushroom harvesting. More in general, we will contribute to answer fundamental questions on manipulation abilities and on skill transfer through meta-learning techniques, and we're expecting to develop new technologies for delicate yet effective manipulation. Moreover, in the long term, the achievements of the project could be extended to open up new opportunities for adoption of robotic solutions in other sectors and used to lower the barriers of robotics deployment. Thank you for your kind attention.
Ladies and gentlemen, my name is Claes Hjort. I'm a professor in materials science and head of the microsystem technology at Uppsala University. I'm the coordinator of the European project Soft-Milli-Robot, or Sumiro, which started this year with a duration of 3 years, a budget of €3 million, and 9 partners. Sumiro's goal is to build a swimming soft micro-robot, biomimicking flatworms, and by its large surface and compliance, it will become the first micro-robot ever to have energy autonomy so it can locomote for longer times without a dedicated infrastructure. To go where no one has been with 30 years of trials, energy autonomous micro-robots are like a Formula One car, with its main reason to demonstrate what is possible and inspiring by going beyond state-of-the-art. For that, we have identified 8 fundamental technologies we have to master. Traveling wave locomotion for swimming soft micro-robots, ultra-flexible high-efficiency solar cells that can withstand water, thin and flexible multi-layer capacitors, ultra-low power visible light backscattering communication technology, ultra-low power nano-MOS-based gas sensing, stretchable RF electronics and soft digital printed circuit board technology, high-efficiency power converters, and soft actuators and autonomous insect-sized soft robots. This is a high-risk, high-gain project, but success in each technology will have impact. Of course, the largest impact will come by proving that micro-robots can be energy autonomous for longer times, opening up for robotic solutions that we have dreamt about for decades. You can follow us on our homepage on Twitter, LinkedIn, and YouTube. Thank you.